Well, hey, everybody. So for those of you who looked at the schedule and for those of you who didn't, the title of this panel is AI and Ethics Beyond Killer Robots and Trolley Problems. And the way that we settled on that is I've been covering AI for a while. And it's really easy to get sucked into the philosophical black hole of the far future. And what we wanted to talk about today was about what's going on right in front of us and what sort of ethical considerations we have to deal with from a practitioner standpoint today. Because as it happens, there's stuff that's real, and then there are killer robots that are probably a little ways out. So to kick the discussion off, I'd love to get started. If we could, on the panel, just go down and give us a short bio about who you are and what you do and what your background is. That'd be great. Leisha?
All right. So my name is Leisha Lee. I'm a principal with Amplify Partners. We're a VC firm that focuses on seed and Series A investments in the enterprise. So the three core pillars are infrastructure, security, and machine intelligence verticals. As for my background, I joined about a year ago. Before that, I was finishing off my PhD at Berkeley in the statistics department on deep learning, formerly a mathematician once upon a time, and also did data science at two consumer-focused firms, Pinterest and Stitch Fix.
Okay, good. Hello everyone. My name is Terran Ziai. Was most recently CTO of Voyage, where we did self-driving taxis. Before that, worked on perception systems for the autonomy group at Apple. I'm allowed to say that now, fortunately. Before that, I was also doing perception work for the US Army, US Navy, ground-penetrating radar for Humvees, as well as sonar perception for nuclear submarines. I also did a stint where we tried to figure out how it is the brain tries to do vision in monkeys with NIH. That was really cool. And right now, I'm working on a stealth startup. Does not have a name yet. Fortunately, that's why you see stealth up there. But the focus there is going to be more on what can we do for what's called higher level perception, more robust predictions, things that are safe that I believe will allow us to get to true autonomy, which is a very hard problem, of course. So.
Hi, good afternoon. I'm Radha Basu. I'm a founder and CEO of iMerit Technology Services. And in case you all believed Gary Kasparov this morning when he said he was the oldest in the room, he was wrong, because I was sitting right back there and raised my hand. No, I'm kidding. iMerit basically works with AI companies to enrich and label the training data so that they can get the best results out of the algorithms. We have 1,400 people in computer vision, NLP, and content services. And a very interesting thing, and we'll talk more about this in the panel, is we have good diversity. We have 53% women, and across India and in the US and New Orleans. And many of them come, and this is something I'm probably the proudest of, from a social impact background, where they come from marginalized communities or families. And so getting into AI services is a big jump for them. It's their first digital job, sometimes their first job. Very young, average age of the company is 24.6. So, and I think I make up the 0.6. And come from many years in technology and worked for Hewlett-Packard for 20 years, then started a software company, took it public here on NASDAQ in self-healing software, and then started iMerit about 6 years ago. So it's my background.
Thank you. So first of all, thanks for joining us. I think it should be a very lively panel. Hopefully some debate too, actually, because I always enjoy the debates in the panels. But I'm chief architect for IBM Watson. I hope it's all on your badges, so it doesn't need introduction per se. But I'm technically responsible for Watson. My background is in optimization algorithms and distributed systems. I spent 20 years of my life in research at IBM Thomas J. Watson Research Center. So my blood is blue, and it's research. Last 3 years, I've been leading Watson. And really, the stake in the ground for us is really AI for businesses. That's where life really, where the rubber meets the road, and the problems get really messy. I usually talk about cats and dog syndrome. It does get beyond cats and dogs and my cousin Vinny and pictures and so on. It really gets very, very real. And that's what I'll talk about later on in my talk as well, where rubber meets the road. Thanks.
Cool. All right. So Radha, to jump off on your introduction, I'd love to get started talking about algorithmic bias, because when we think about ethical issues in AI, it's one of the things that comes up most often. And so I'd be interested to get a sense from you. What sort of examples are you seeing, and what sort of strategies do we have to help mitigate that? And then let's open it up for the rest of the panel.
Yeah, I think algorithmic bias is such an important part, because the end of it, if AI, and not if, as AI is emerging from research into business, into commercial applications, which is what we all want to do, it is really important that the machine that's being trained is trained in a way that is truly inclusive. So algorithmic bias could be, out of our 1,400 people, about 600 of them are trained in computer vision. And I think we've worked, at least close to this, worked on more self-driving cars, street scenes than like 15, 16 million street scenes. And it's really interesting that when we've seen differences between women labeling and men labeling, and looking at women who have never driven a car labeling the street scenes, some of the purest data comes from that. So there's algorithmic bias that might be to gender, to context, et cetera. Another example I can give, and these are some of the exciting examples, because what AI makes possible, and I don't look at the negative side of what AI makes possible and can be commercial, is the fact that you can do this. So we have a sales guy in Colorado, a young fashionista in our New Orleans office, and a young Muslim lady in Métier Bruce, far away in a very cloistered community. And they're working on looking at style categorization for one of the large build companies. And then you see the style categorization to be so different. And when you look at that, you realize that you're bringing in different elements of what could be biased if it were all done by Silicon Valley. Even in this room, it would be very biased. So I think bringing all of that together is what will take AI from its more research-oriented approach now into truly full-blown commercial applications.
I think I wanted to just chime in and at the beginning of the panel, and I don't know, see if rest of the panelists agree with me. I'm going to make a statement which may surprise you, and then I'm going to sort of clarify it as well. Bias is not bad, first of all. In fact, I would even argue bias is needed. There is no modeling without bias, by the way. If there was no bias in data, I wouldn't model anything. There is good bias, and there is sort of bias that you really don't need. So that's where I would introduce the terms bias versus fairness. Now, if there was, let's take an example, very simple example. People who can afford loans should get loans. Good idea. That means if your net worth is, you can afford a loan, your net worth is high. The data is biased, by the way. There are people with low net worth, there are people with high net worth. The data is biased. But people with high net worth can get loans. Now, everything else being equal, a white person versus an Asian versus a black person, you should not distinguish between that. That is fairness. So to me, there is a distinction between bias and fairness. In fact, since I come from optimization algorithms background, none of my gradient optimization techniques will work if there was no bias in the data, because the surface will be uniform. I look around myself and say, where should I go? I'll say, you should just stand here, actually, because there's no bias in the data. And so we should really, as technical people and as scientific people, we should get beyond the hype of bias, and we should really focus on fairness. I think certainly that is a fair topic. I'm not very sure, treating bias as something, a dirty word in itself is not a fair topic, because bias is a requirement for modeling, and I wanted to make sure all of us at least either agree or agree to disagree on that topic. But to me, it is very technical, and we should focus more on the fairness and ethics aspect. Those are very important, but bias in itself is not bad. In fact, I would even say that all of us are biased. We are biased by our backgrounds. One good thing about computing systems or models is you can detect the bias and you can mitigate it. Interestingly, it's very hard to first of all, even detect human bias, and mitigating it, just try convincing the person next to you, actually. They may agree to you, they may shake their head and go back and do the same thing again. So to me, it is fairly interesting, because computing systems and modeling systems offer you opportunities that we didn't have before as well. So I would like to take it at a much more technical level than the level which is sort of the narrative and the hype and the philosophy of it. Thank you.
I don't think bias is a hype. I think having different opinions go into the machine algorithms, I think that is really critical. Whether you have this, as I was saying, a salesperson from Colorado looking at the same image, or someone in Métier Bruce, or somebody else in New Orleans, that data going into training data is really important. The fairness comes in when you look at it purely from a technical point of view. You could say, I have 1 million images, and they're all going to be trained in a particular way, or speech to text, for example. I'm listening to these kinds of narratives, and I'm converting it into text. And you can have excellent technologies to do it, even achieve 80, 90%. And then somebody comes along with a little bit different accent, or maybe it's just a softer voice, or something, and maybe brilliant. And you want to be able to capture that to both the efficacy of your technology itself, but also for making this actually work in the real world. So you're right, there's bias, there's fairness, there's ethics, and all these three have to come together. But having different kinds of data, if that's what you mean by bias, I fully agree with. Yep.
Yeah, just to add my perspective here, I think it's clear that our models are, they're statistical models. So you input, output, there's no introspection there. So there's no doubt that there's bias that you can't get rid of. But to abstract away from that problem, it's more so how do we make sure that we have levers and interpretable frameworks to understand and debug the models that are so influential in other parts of life. So it's not necessarily in abstraction, yes, there's bias, but like where do we sort of, as humans in the loop, contribute to defining the objective functions so they serve values that we care about? So I guess in one of the actionable things there is I'm very excited about the interpretability research that's coming out of academic communities and research communities, mainly because they sort of, they try to intercept in many different parts of this problem. Like before you create the model, you do exploratory analysis and visualizations to understand where your data has, there's the outliers, and like basically become more aware of the biases of your data sets. And then once you output a model, how can you create mechanisms to allow you to understand what the model is doing? Because a lot of these things that are coming out from deep learning are in fact quite black box, right? The whole point is that you're not doing feature selection, you're allowing gradient descent to do the feature selection for you. So given this, how do you work within the framework to create an interpretability so you know how your models are actually affecting the people that these things are deployed on?
Yeah, and just to add to that, I mean, essentially, this has been like I said before, but yeah, there's like the mathematical bias that your data will bring in based on the statistics of the data, garbage in, garbage out, CS 101, right? I think the responsibility for all of us is to make sure that, hey, should I deploy this machine learning model, which is really just a statistical model? Again, yeah, there's no introspection there. There's no reasoning per se. You have to just make sure that the conclusions it's giving you or the results it's giving you are not going to result in some sort of what we would consider political bias, let's say, right? And if it does, we should be able to go back and say, oh, wait a minute, what can I kind of tweak here? Do I have like some anomaly in the data? Do I have like some offset in the data or something that I can take care of? You know, so yeah, there's mathematical bias, the B in the equation usually, and then there's the political ramifications of having some machine learning algorithm give you an answer that we would politically say is biased, and what to do about that. So yeah, important to separate those two, but definitely a problem we should be very much aware of. And,
so speaking of things that are coming out of research, Leisha, when I was talking to you earlier, one of the things that you brought up was the idea of adversarial examples and what they have the potential to do to some of the systems that we're building. Would it be possible for you to share with the room sort of what's the state of what's going on and why is it a problem? And do you see any way to mitigate it?
Absolutely. Okay, so I think most of the room probably has heard of what adversarial examples are about, but just for the few who don't, the quick sketch is basically for a lot of these models, not limited to deep learning. You can come up with perturbations that are fairly random and also just undetectable to the human eye, which makes the classification with high certainty say that something looks like a cat that clearly looks like a dog. So basically renders your classification wrong. And the thing that is I guess, it came out of a couple of papers, I think, several years ago, starting with Christian Zegedy and a couple of people from Brain, but has really morphed into this area where you show that these examples are actually quite robust to create in the sense that even without access to what the model is, you can create them very easily and with just like a high degree of generality. So what that means is that you can really attack the kind of attacks that you can make on these models, which are being served up for both self-driving and like a lot of these very high stakes areas. You can, without access to what the model looks like, be able to attack it by serving up adversarial examples. So with current research, I mean, I was just coming out of iClear in Vancouver, which is this big deep learning conference focused in the academic and research community. And it's great to see that there's a lot of research that's happening in the area. What's troubling is it does feel like a bit of an arms race because you have these robust methods to create adversarial examples, and then people are trying to then through different approaches of either through training or also in the kind of ways that you can tweak the actual model architecture itself, try to make itself more robust to adversarial examples. But it's still in more of the nascent stages, I would say, as a general. And I can open it up to more of the practitioners in Europe, especially for autonomous. I'd love to hear how you guys think about addressing the problem.
Yeah, no, of course, it's a very good question. So I think when it comes to autonomous driving, which I think is another one of these topics we're going to talk about today, but the adversarial question really comes down to how you architect your system, right? So if, for example, you have a classifier that's going to completely fail because one pixel is off and it was optimized the wrong way, I would say for something as safety critical as self-driving car or a plane or anything like that, the architecture is wrong, right? We should not have classifiers that are known to be this brittle. What you want in a good architecture there, and I can go on and on about this, is you want to have graceful failure for autonomous driving, right? You want to make sure that if you have something fail, there's something there that can catch it. So what this comes down to very concretely is that in self-driving, you don't really need to know what something is, right? You just need to know that something is there and that you shouldn't bump into it, right? Which is kind of like what me and you do, basically, right? We might not know what all these objects are from a class level, like the semantics, but we know enough about spatial, we have enough spatial reasoning to know that there's something here occupies volume, I occupy volume. If I was to go this way, I'd probably bump into it. And that's kind of enough, right? So in that sense, if I had a classifier misclassify this, so what? right? That means you have a good architecture in that sense, right? If, on the other hand, I was making my system where I would detect stuff by classifying it first, then I would open myself up to being like quite brittle to adversarial attacks and things like that. So these are broader architectural questions that we have to take care of in the self-driving community, basically, and make sure that, sure, maybe your classifier fails, but you should still know that there's something out there that occupies volume and that you should not hit it. And that should be your lowest layer of safety, in a sense. So.
I would say I think a lot of focus in the adversarial attacks or sort of taking it the other way in adversarial mitigation techniques or GANs in other ways has been, a lot of focus has been on the vision side. There is a very interesting aspect of it from textual data, which to me, and I'm going to pose this problem to the academic community as well. We have a large research group who is looking at problems. But what at least we see in the enterprises, vision is a part of it. But a lot of data actually centers around textual data, actually. A lot of knowledge of the enterprises actually is in the text form, whether that comes from documents or wherever it comes from, actually. It resides in all kind of textual documents and tables, sometimes structured, sometimes unstructured. It's a very interesting area for further investigation on adversarial training and attacks for what can happen in a textual domain. And in particular, when you have an assistant that is helping you in terms of the customer service when it gets deployed, what can happen when the adversarial attacks actually go on. We have more recently, IBM open sourced a toolkit called ART on Adversarial Robustness Toolkit last month, which has gotten a lot of traction. I would invite the community more broadly to look at that toolkit. It is there on the GitHub. You can go and look at it and invite the community to start at least leveraging it, contributing to it. It's totally open as well. But to me, a lot of research is needed in the dimensions that are left more unattended, so as to say. Because a lot of focus has been there on the vision side, where you can determine, hey, I perturb a pixel, what happens? What does it mean to perturb a text? Do you perturb a letter? Do you perturb a word? In which dimension do you perturb it? Is it on a vector dimension? So I think even the fact of perturbations in the text dimensions are not obvious. However, some of the implications can be quite serious. So,
I would actually, in this case, agree with you. You wanted some controversy. See, because we have this large number of people working across, whether it's computer vision or NLP, so text data, vision data, and content services, sometimes it feels like being in an ER where lots of different cases come in and out. And in a particular case, you have to develop real depth, but then you also see lots of other cases. So we're able to compare between computer vision around, and there's so much talk with self-driving cars and semantic segmentation and dense pixel segmentation. And you can do it down to 1 pixel. We do more bounding box and all that at the pixel level. But then, as you said, you look at the text and the adversarial perturbation at the text level. And as you're working through NLP, and probably 40% of our services are around the text area, I think there, we actually don't even know exactly what are the results of that perturbation. It's a little bit easier and more known in the image space. But even in the image, there's so much talk about self-driving cars, and I love that because that's a large number of working with Figure 8 and their customers as well. But there is so much other things. I mean, when you're looking at cancer cells, or you're looking at weather analytics, you're looking at geosat imagery, there's all of that. Then you start to look at the perturbations there, and the adversarial perturbations are also, I think, not as well known.
I think with regards to text data, just to finish off the thought there, is that it's not, the classification problems are less clear. Nonetheless, I have seen some work in the recent iClear about RNNs for sequence-to-sequence models with adversarial perturbations as well. So definitely look at those papers. But with vision, why it's become such a focus in the community is that it's the most mature area of deep neural networks. And so we see that being deployed in a lot more places, and that's why there's a more pressing problem of being able to address this. But with that said, if text data is extremely prevalent, so as long as we're developing models that are also summarizing and classifying, then we're going to run into the same kind of problems.
Well, speaking of pressing problems in natural language, I feel like I would commit moderator malpractice if I didn't bring up Google Duplex, the system that they showed off at I/O this year that was able to imitate a human being. And it's something that spurred a lot of conversation about, as we're creating these systems that can behave like humans and can seem like humans to other humans, what sort of ethical responsibilities do we have to the people who are using them around revealing their automation or not? And so that would be sort of my starting point, and I'd love to throw this as a toss-up question to the whole panel. What do we do? What are the strategies for making this seem less creepy?
I mean, I think the easiest thing is for just from a comfort standpoint. I actually don't think I would mind personally if it was a robot or a person there. I mean, I think I would find out soon enough since we haven't solved the Turing problem yet. So, but I think maybe the easiest thing is just for it to be best practices where it just says, "Hey, look, I'm a bot, but I sound like a human. Would you like to order a coffee now?" And then we can go off that. So that might be like my first order maybe solution to that issue, I guess. But
Jeff, anybody else? I actually, I don't know, enjoy figuring out whether it's a bot or a human. Times when it kind of makes you really think about AI when you're working in the field and you're working on it every day. It's kind of nice to step back and say, I'm the user of this, and where am I getting this information from? And think about the insight into how this is being trained. What did this bot just tell me? It guided me somewhere based on my choice of what I had bought earlier. And it was training, the bot was trained based on that. And I might be doing it with a young child next to me, which might be very different from the way I was looking at it. So sometimes it's actually good to have these and to think about the effect on you of not knowing whether it's a bot or a human and then figuring it out. But that's just a personal bias.
Yeah, and I think there's also been maybe like the reverse problem where I think I've had situations where I'm convinced customer service agent is actually a robot. It's just been that bad. Yes. It's just been that bad. Maybe they're saying, no, I'm actually a human, really. Sir.
But they have a playbook.
I'm just reading off a script, and I sound exactly like a robot. Exactly.
So, yeah.
So I think there are two aspects of what Duplex actually had. One is, if you look at, it was a very narrow domain, first of all, where the question and answers or the dialogue is what I'll typically describe as a short tail. You should distinguish between dialogues that are short tail and long tail. Long tails are much more deeper, much more nuanced, typically in knowledge workers or experts go through those kind of actually dialogue. And short tail will be, quote unquote, Alexa, what's the capital of New York? Can I book an appointment for here's a haircut? That kind of stuff actually. And I do believe I was quite impressed by the human-like speech part of it. That certainly was very impressive, and you find it creepy as well sometimes because you don't know exactly what it is. I would agree with it, but there is another aspect of it which was certainly impressive, but we should distinguish between what will it take to solve a dialogue problem in enterprises versus can I book an appointment for a haircut. And what's the capital of California or New York? Or, those are very, what I describe as short tail problems. For such kind of technology to be successful in businesses, it's going to take a good combination of short tail and long tail dialogue solutions, which I think part of it Google demonstrated in a very narrow sense, which is the underlying technology. But to me, a lot of progress need to be made in that area, where I was certainly I think I was very impressed with the text-to-speech part of it, which I do believe, I'm a father of 2 girls, I would like to say the bot having said, I am a bot, actually. It is a good idea.
Yeah, so I mean, I think I agree that in these narrow domains, passing the Turing test is not news. The thing that is what made it super impressive was the text-to-speech. I mean, this is actually research that came out of DeepMind about a year and a half ago. WaveNet was not very efficient back then, but just in a span of a year, we were able to deploy this, and now it's on all of, like Siri, not Siri, Google Voice uses this. So that is the part that kind of is very scary. So when you're thinking, I mean, I'm very excited that this could be used for my restricted domain scheduling problems, but if you're thinking about these call center use cases where the only bottleneck to ramping something up for collection agencies is just the number of people you need to train to go through your programmed decision model of like how do you collect money from people, then you can actually use this kind of technology immediately for that. So I think there are actually very severe ethical ramifications about like how do we curtail malicious uses of these easily deployable, now very efficient and very human-sounding technologies. I think probably somebody's starting a company right now doing this for call centers. So the government probably has to jump in with some policies about, well, if you're going to be collecting money or fooling old, untech savvy people with these things, then like what do you have to abide by in order to prevent that? Because we can't sort of just let the market decide.
I think there's also a lot of nuancing and depth in this. There's the technology of doing speech to text, the technology of, whether it's a call center or somebody responding to you as an assistant, et cetera. But then there is the nuancing of how that reflects you, your views, your use of wording, which is different from, on the same topic, maybe a little different in the way you use it and the way I use it. I'll share one little quick funny story with you. But several years ago when we had the startup with Sportsoft, young company, we didn't have a lot of admins and stuff, so it created this virtual assistant, which is now a real Watson virtual assistant, but that was just a name. And then I would, because I couldn't get a meeting set up with other CEOs without having an assistant. And this virtual assistant would respond on my behalf, except I was the virtual assistant as well. And there was one time when, the wording would be different based on each of these. And I think about it now as we look at training AI for these, for virtual assistants. And there was one time when somebody's assistant responded back to my virtual assistant and said, "Oh, you have such a great boss. I wish my boss was like you. You know everything that you need to know about your boss." And I was thinking at that time, and I think about how these, when you train AI, you have to really know how to think about, if you're an assistant, how to think about the person that you're an assistant for and reflect how they would talk about things.
All right. Well, we've only got a few minutes left, but one of the topics that I wanted to open up was the idea of what responsibility do practitioners have in, as we start navigating this ethical minefield ahead of us? What responsibility do, individual engineers, data scientists, companies have as far as getting ethical results out of the AI systems that they create or that they're working with partners to create?
Yeah, so I think maybe I'll go first on this. So the practice of, again, like self-driving cars, right, is I think one of the most, I don't know, hyped use cases for AI in a sense. I like to say that, I mean, the very first thing I would say that is the responsibility, I think, for practitioners and people in the industry doing a lot of this is to try to also de-hype a little bit, right? So when it comes to, for example, self-driving cars, I like to say that it's not so much that we use AI, like artificial intelligence, it's that we kind of use a condensed human intelligence, CHI, right? There's no kind of reasoning under the hood going on there. We're very good at pattern recognition these days with DNNs and so on and so forth. But at the end of the day, there's no reasoning that's happening there, right? And so just even setting the baseline tone there, I'm saying, hey, look, these self-driving cars, they're not looking at you and judging you and kind of saying, okay, I'm going to run you over, not run, they're still, as far as we're concerned, really, really dumb machines. I mean, they're probably dumber than like your pet cat, as far as collision avoidance, And part of that is because we're still not there yet with AI. There's still a lot of things that we have to conquer there, specifically when it comes to reasoning, specifically when it comes to decision making, right? Specifically when it comes to being able to navigate seamlessly, make those kind of decisions. And so I think the first thing I would say there is that it helps the industry, it helps the field, if we're humble about what we say, in the sense that, hey, look, self-driving cars, they don't have their own agency just of yet. There's still a lot of so-called, modules that we kind of handcraft and design. We use deep neural networks in some components of it, but at the end of the day, this is not artificial intelligence in those machines. Really, it's condensed human intelligence, is the way I like to say it. As my part to de-hype a little bit of the field and maybe add a little bit more groundedness in it. So I would say that one of the first things there is to be aware of that and be cognizant of that and try to de-hype in a sense. So because I think the more you de-hype, the more we can have more honest conversations about the impact of these devices. Maybe that's a bad word. The addressability of these devices. So.
I think that the fact that we are having this ethics discussion now in a variety of different ways is core to AI. And I loved Gary's term this morning about augmented intelligence, which I really think is what it is. It's human intelligence in the loop of machines, with machines. I think that the addressing it now and making it core to every person working in it, for us as a partner to Figure 8 and partner and as doing the labeling for a lot of our clients, it's really important for every individual to understand and to be trained on and to think about that there is the importance of the fairness and the ethics in the work they're doing, and that it is indeed every single step you take has an impact. And I really think it has an impact on the way the machine is learning and how they would be using it in the future. So I think it is really key to scaling AI and making it commercial applications is to kind of address it right now and make every person part of it. To me, it's a little bit like, I think of it as a medical analogy, in that when we go through and when clinical trials happen and you're releasing drugs and things like that, there is a real efficacy and a lot of process, a lot of procedures, and a lot of sharing of that data. So if somebody came up with a great self-driving car, and that had, it's like a magic safety belt or whatever it is in the equivalent, what is the ethics of sharing it with others so you make all self-driving cars really really safe? But I don't think it's just to do with cars. I think it's to do with cell categorization. It's to do with image analytics in diseases. So this becomes, this discussion we're having, to me, is what will enable AI to become so commercial, because it will be ingrained into the way we think, breathe, train, and use AI.
To me, I'll just say sort of one sentence here. AI is actually optimization algorithms. Putting all of these on engineers regarding you, we trust you to build ethical models, trust but verify. Build tools and methodologies that check skewed data, biases in data, unwanted biases in data. We need to go through the same level of discipline and methodologies we have gone through in other disciplines. We should take away almost this word, artificial intelligence. These are optimization algorithms. We have had them for a long period of time. We need to build methodologies, checkers, mitigators to really. If we were using optimization algorithms, I don't think that people will be as scared as well, actually, as opposed to you introduce the word intelligence into this, and somehow it sounds actually really, really creepy sometimes as well. But I would really say trust but verify, build checkers, build mitigators, and build optimization algorithms.
It would really behoove us as a community to look at, and we've looked quite a bit into this, is to look at those checks and balances and qualities and just the way data is gathered when companies go through like clinical trials. I know it sounds very complex, and it is, but the veracity of the data and how it retrains or recodes something based on the data you get back, there is some real process, and I truly believe that getting the processes and things into it and not being scared about it, oh, that'll lengthen the time, et cetera, but that will make AI get into the space, into the commercial space that we want to.
All right.
Oh,
Leisha, I'm going to
Rob.
let you have the last word, and then.
Okay. So on a succinct note on that, basically make sure that your metrics of success are aligned with principles, like ethical principles, and that begins with having them in the first place. So define what those principles are, and because for an organization, if you define your success metrics to be, very simple, then whatever the organization does, they're going to try to go for those principles. So if you have to start with ethical goals to begin with, and then make sure your success metrics actually align with them.
Cool. Well, on that note, thank you all so much. Could you please join me in thanking our panel?